This is the third and the last part to our free, beginner-friendly course to make your first game with the Godot game engine. In this one, you are going to learn about user interface, creating a menu for your game, adding some score as well, an end screen. I'll help you make sense of Godot's powerful, yet a little complex user interface system. Now, before we get started, I want to remind you that this course is made possible and sponsored by our premium courses. You can find an extended edition for $10 that's going to give you some bonus content. Link in the description below. You also have the table of contents in the description and the links to the previous two parts. But that said, enjoy the tutorial. See you at the end. In this first part, we're going to create our title screen, one that kind of resizes fluidly depending on the screen that the player is playing with. Then we will create reusable UI components, so buttons that allow you to start the game, to change scene, to be precise, and to quit your Godot game, your applications. Let's get started. So here I am starting where we left off in the previous part or chapter. The level might look a bit different because this is the level from the final project and not the one I created live for the tutorials. But we're starting with our level here and we want to create our title screen. For that, let's go to Scene, New Scene, and we're going to create User Interface. So in Godot, when you add a node, all the nodes under Control, the green icons, are user interface nodes. All of these have special properties that they share. If you select your control node and go to the inspector, you will see there are quite a few of them actually. The anchor, margin, grow direction, the rectangle, which is the rectangle that you can see in the viewport right now, hint focus mouse, etc. We're not going to see all of them because the system is quite complex. It's designed to allow you to make interfaces like the Godot editor itself with tabs, with resizable columns, etc. You can use them to create your tools and plugins. The Godot itself, all the user interface is made with this system, with these control nodes. For an example of what you can achieve, here is RPG in a Box, a tool to create 3D voxel-based RPGs made entirely in Godot. So everything you can see in the video right now is made with this UI system. Now, going back to our user interface, the first node is going to serve a bit as a container. So it will be the main base for our screen that we can easily resize with the selection tool by clicking and dragging on one of the handles. So everything will fluidly rearrange inside of it based on the parameters we'll give to the control nodes. We'll call that our main screen. Now we're going to start by adding the background. So expand the assets folder and you have background.png for that. Click and drag it on the view and you can keep the Alt key down, as you can see in the top left, to change the node type. We don't want a sprite here. Instead, we want the texture rectangle. Texture rectangle is a resizable texture that you can use for user interface. And so the texture will appear where you dropped it, where your mouse cursor was when you released the mouse click. Now we want to have it fit our main screen, our user interface here. So select the background node, and that's where we're going to start using the layout menu that appears in the toolbar when you select one of these green nodes. Layout contains a number of options to scale, anchor, and move your UI nodes. So go to the layout menu and select full rectangle. This is going to move and resize your background texture so that it fits the full rectangle of its parent. Let me select the expand option here that will allow us to resize the texture or crop some of it. With the background node selected, I'm going to resize it to make it much smaller, and again go to layout, full rectangle, and you can see that it scales to fit the main screen here. Now, if you select the main screen and you resize it, you will get the background to resize alongside it. So select the background node again, and in the inspector, you have a stretch mode that you want to change so that it does not get scaled, but the texture gets cropped instead. So you can choose tile. And when you choose that and you start to resize the background, you will see that the texture will only get cropped. But if you expand it on the x-axis, it will get expanded. Next up, we're going to add some text to our title screen. So select the main screen node, press Ctrl A, and you want to look for label. Label is a basic text box if you want, very simple. So you're going to see it added in the top left of our view, and the node is very small. With the label selected, the first thing you want to change is the text in the inspector. So let's call it my first game, something like that, my first Godot game. Well, I'm going to place it at the center of the screen. So go to layout with the node selected and center top. This will make the node's position relative to that center top anchor. So press the W key to select the move tool and click Shift and drag it down to make the node live at an offset, vertical offset from the top left corner. The text a bit small, we're going to change it in the next video, but for now we're going to work with that. So selecting the main screen, again, I'm going to resize it, and you will see that the text stays centered horizontally, and it stays at a fixed relative offset from the top corner here. Now we're going to add the buttons. So let's add a button. You want to press Ctrl A again, look for the button node, and add that. Again, it gets added to the top left of the screen. We want to resize it a bit with the select tool active, and we can add some text to the button as well. So you can call this one play for the play button, and we're going to duplicate it. So select the button scene, Control D to duplicate it, W, shift click and drag down with the shift key down to move it down, and the second button will be quit. Now, the thing is, you want to use these anchor system and the layout to make sure that the position of your control nodes is relative to the parent, in this case the main screen node. So select the two buttons, and just to show you, I'm going to move them manually to the screen center, in which case when I resize the parent, the main screen, the buttons will not follow, right? Now the thing is, we also want these buttons to stay aligned, to be contained in some kind of box together. For that, you have a special type of nodes in Godot, the containers. So select the main screen, and let's add a new node, not button this time. We're going to look for the container node. And when you look for that, the main container, the container class, is designed to allow you to create custom containers via code. But you have a number of nodes that you can use by default, especially the box containers here. HBox container is going to be a set of columns if you want, and VBox container is going to give you a set of rows. So let's add a VBox container. With that VBox container selected, we're going to go to Layout, Center, so it's going to center the node, and then we just have to select our two buttons in the inspector, click and drag them inside the VBox container, and they will magically align and resize to fit the VBox container. So then you want to change the size of that VBox container node. So you can click on one of the corners with Control and Alt held down. So you're going to resize the box so that it gives a bit more space for the buttons. And then you will see that the buttons have some kind of minimum vertical size here, which is actually based on the text size. We want to force the buttons to expand to take all the available space in the VBox container. So select the two buttons, and when you select several similar nodes like these and you change properties in the inspector, you're going to change the value on all of the nodes, all of the children. So we're going to go to the size flags category, expand it, and then you will see you have horizontal and vertical flags. These trigger some special modes or behaviors on the control nodes. Expand vertically means that the nodes will resize vertically to take all the available space, and they will compete for space. So for example, if I remove the expand size flag on just one button, look at what happens. The other button expands to take as much space as possible, respecting the minimum size of the other button. If both of them have the expand flag on, they will share the space half and half. And then you have a stretch ratio value that can change to make one node take more space than the other. With that, we have our base menu. So I'm just going to move the label a little bit, and we're going to do a few more things. First, we're going to rename some of the nodes to keep our work clean. So the label we'll rename to title because it's the game title. For VBox container, we can say menu, that contains the buttons. Then for the buttons, we're going to call the first one play button, and the second one is going to be the quit button. We're also going to do one more thing. We're going to save these nodes to separate scenes so that they become reusable UI components. So right click on title, save branch as scene, and go to source. We're going to create a new folder. We'll call it user interface. Okay. And inside that folder, we'll save our title as a scene. Right click on play button, save the branch as scene. Same thing, it will be in your user interface folder by default, so save there. And finally, same thing for the quit button. Because we will reuse these nodes, the title will be for any text that should have the title font in our game, and the buttons to play and quit are going to be reusable buttons. But with that, save your main scene. We're going to save the main screen here in a new folder once again that we will call screens. These are going to be entire separate screens from our game levels. The main screen, save. You can do one last thing. It's to go to project settings, the run category, and our main scene, the one that loads when we press the F5 key, was our level 1 until now. Press the folder icon, click it, and let's use our main screen instead. So go to the screen folder, double click on main screen to make it so when you press F5, it will launch your main screen. And you can see that you can already interact with the buttons and you will see your text and all. But for now, nothing's happening because, of course, we haven't coded anything. Anyway, in the next part, we're going to add the font to make our text readable. Okay, so we want to make the text readable, and to do so, we have to change the font used by the text. We can't just resize the box and have the text scale. Right now in Godot 3.1, 3.2 is the same. So we're going to see how to do it the right way, quote unquote. If you go to the file system and you look at the assets folder, you have two fonts prepared for you. Font default, font title. These are reusable resources that you can plug in any node. So for example, on the title here, you can go down the inspector to the custom fonts category and drag and drop your font default there. You might have seen that done in other tutorials. But this is not the correct way to set a default font, actually. You don't want to use the custom fonts for that. So I'm going to go back and deactivate the custom font. Instead, we are going to use a UI theme. So here I am in a more advanced version of the project to show you what themes are and what they do. I can apply a theme to any control node using the theme property. So a theme is a resource that you create in Godot, and when you apply it to one node, all the children, the entire tree of UI nodes, inherits from the properties of that theme. So you can then edit that theme to modify how the entire UI looks. For example, you can set a default font, and this is what we're going to do now. So coming back to our project, let's, in the inspector, use the Add Resource button. It's in the top left corner. Click that, and you want first to add a font. We're going to see how to create a text font. So you type font, and we want to use dynamic font. Create that. So this is the type of resource you use if you want to use a font like a OTF or TTF file, the kind of fonts that you can find on your system here, all these fonts that you have installed on your computer. You will need to go find the file, it depends on the operating system you are using, and put it in your Godot folder, or you can go download them from the internet. In here, for example, we have Montserrat from Google. And then, with your dynamic font resource open in the inspector, you want to expand the font category and click and drag your OTF, TTF file, either is fine, on the font data here. With that done, you can then change the size of the text by changing the size setting or property. It's in pixels, by the way, so if you do 24 pixels, it means that the letters will be 24 pixels high. With that done, you want to save your resource. So at the top of the inspector, you go to the save icon and click Save As. And we can then save it in our assets folder at the root of the project and call that your dynamic font. You don't have to create it. I just wanted to show you what the process is like. I'll save this one as our new dynamic font. From there, you want to create a theme. A theme is also a resource, so we're going to use the button in the inspector. Click on it, look for theme, and you should have only one resource to create that. Create that, and our theme, by default, displays at the bottom of the screen here, and it has only one slot to set the default font for our user interface. So you can then drag and drop your dynamic font.tres file and place it in the default font slot. And you should see the text updates in the bottom panel. This bottom panel, the theme panel, is just here to give you a preview of your UI theme. Then we'll see in the extended edition that you can use the edit theme menu to add more items to then start to change the style of the buttons, the distance between elements in your UI. So you can use that a bit like CSS in the web development world to style your user interface. Anyway, we're going to save that theme as our UI underscore theme.tres in our assets folder here. Click save, and then select your main screen node, go to the theme at the bottom, and you want to click and drag your UI theme.tres into the theme slot. You should see the fonts change instantly. Now, the title itself went a little off to the right. We want to fix that. But as we saved our title, play button, and quit button as separate scenes, we want to open these scenes to go change the default property of our title here. So open it in the editor, and for our title, we want to make sure that it is aligned center. So the text is centered inside the box that you can see here. Then we want to create a new font, or rather use the font title that we created for you, the same way I showed you moments ago, and go down to Custom Fonts and click and drag the font title into the slot. I'm going to change the default text to title here, and again go to Layout, Center, or rather we're going to do Layout Center Top, so that the text position is relative to the top center of the screen or of the parent node. Save, go back to your main screen, and you should see the font changed. Then we want to do the same again, Layout Center Top, to reset the position of the node, and you can move it down by clicking and dragging with the Move tool selected or Select tool, then Shift to constrain to the Y-axis. And with that, we have our UI setup. We can move on to the code. Okay, so now we're going to code our play and quit buttons that are currently not doing anything. To do so, we're going to open our play button scene. So click the button to open it in the editor next to the node, and we want to add a script to our play button node. Click Add Script. By default, it should go in the right spot, user interface /playbutton.gd. Note that I'm using the empty template once again. Click Load or Save the script to open the script editor. We're going to make the button do something, change the scene when we click it, or rather when we release pressing the button. To do so, we have to use a signal. Select the play button, go to the Node tab next to the inspector, and you can see that you have a base button category with a few button-related signal. Button down is going to trigger when you press or start pressing the button down, when it is down. Button up will trigger when you release the button. So releasing the button is when I click, the button changes shade. It's when I release the click, that very moment, this is button up. This is what we're going to use here. So select button up, click connect, and you're going to connect to the play button. I'm going to change at the bottom the method in Node to on button up, because this is happening on this node on its attached script already, so we don't need to have a more complicated name. Click connect to go to the script editor and have the on button up function created for you. There we will change the scene. So that is how our play button is going to work. We're going to do that by getting the node tree. The node tree is what you see in the scene tree, but we want to get the one from the game. So you go get tree dot change scene. And then you have to give Godot a path to a new scene. So a path would be anything you will get if you drag and drop a scene from the file system here into the code editor. I'm going to go to the levels folder, for example, and click and drag the file into the script editor. As you can see, this writes the absolute path to the file itself, relative to the resource folder, which is the root folder of your Godot project. Now, we don't want to have a hard-coded path in here. We want to make our button reusable. Actually, we're not going to call it play button in this scene, but we'll call it the change scene button, for example. And we might want to rename the scene as well on the file system. So go to the user interface folder, play button, right click. We want to rename it to change scene button. So go back to the script editor now, and I'm going to add an exported variable. So we're going to do export variable next scene path, and it's going to be empty by default. And I'm going to add a colon to automatically set the variable to a string. And in the change scene call that you can see in there, I'm going to change the string in parentheses and use next scene path instead. All right. Now, we can do a little better than that, because if you go to your change scene button in the inspector, you should have that next scene slot, but it would be nice if we could directly select a file from there. It turns out that we can. So let's go back to the script editor, and after the export keyword, in parentheses, we can give some parameters to tell Godot what this string is going to be exactly. And in this case, it's going to be a file path. So add parentheses after export, and we're going to first tell Godot that this exported variable is going to be a string, and then we want that string to use a file browser slot. So you have a few keywords you can use here, constants. You have file, and you have multi-line, for example, if you want to have a large text field. But in our case, we're going to use file. Save, go to your change scene button again, and you should see the folder icon next to the next scene path. Now you can click that folder icon to go find a scene file in your project. Okay, well, I'm not going to do that here because our button is going to have a different path in every scene where it will be used. So while creating a smart, reusable component, let's say. We're going to do a little more than that. We're going to see how to add a warning if we forget to set the next scene path. Because if you forget to set it, you're going to get nothing as the path is empty, right? You just click the button, nothing happens. So we're going to go back to the script, and first, at the top of the script, we're going to add the tool keyword. Tool allows you to run any code inside of the editor. So this is the keyword you would use to create plugins in Godot, for example. Then there is a built-in feature to give warnings to the user. This is the warning you get, for example, when you add an area to the node, right? That warning icon here. To add that, we need a function called getConfigurationWarning. You should get autocompletion for it, and I will add the string return type. It's going to return a warning string if a certain condition is not met. So let's return next scene path must be set for the button to work. And we're going to do that. So let me expand the view here. If next scene path is an empty string, like so, else we return the empty string. So the warning will show in case we return a string with something inside of it, and that will happen if next scene path is not set, which is the default value here. So save that, and you will see the warning sign appear in the node tab. That is until we put something in next scene path. Sometimes you have to reload the scene or save for the warning sign to go away, but well, we have that set up. With that, now if you save and go to the main screen, we're going to set up our play button. So the next scene path here is going to be the path of our first level. So in the file system tab, navigate to level01.tscn, right click, can copy the path and paste it in the inspector. Then we want to code the quit button. It's going to be a lot faster and simpler. So open the quit button in the editor. We're going to change the layout, say it's going to be centered by default, or we can say top left, just to have a clean scene to work with. And we're going to attach a script to it. Create a new script with quit button selected. It's going to be saved in the user interface folder. And for this one, we're going to do the same. When we release the button, when it's up, we're going to quit the game. So go to the Node tab, double click the button up signal, or connecting it to the quit button. And I'm going to rename the function to onButtonUp. With that, when the button is up, we're going to call the quit function, which is on the tree, the scene tree object. So we call getTree to get that tree object, and we call its quit method. And that is it. With that, you can play the main screen, click the quit button, it'll quit the game, click the play button, and it will launch the first level. Next up, we're going to work on the game's end screen. That is going to be quite similar to our main screen, but we'll see how we can reuse our buttons that way. So let's create a new scene, and we're going to make it a user interface scene called end screen. Let's save that to our screens folder as our end screen. So our end screen is going to have some title, it's going to have some message about the score, and 2 buttons like we saw with the main screen. So let's create that right now. We're going to start by placing the background. So one thing we can do here is grab that texture rectangle, that background, from our main screen scene. Back to the end screen, right-click on the node and select the Merge from Scene option. You want to select your main screen scene, so go to screen, main screen.tscn, and you want to select the branch of the tree that you are going to integrate. So we want to get the texture rect here, press OK. You can use that to get entire subtrees of nodes as is copied to your new scene. We could also save our background as a scene to reuse it, but I wanted to show you that other functionality. We're going to do the same, merge from scene, go get the main screen, to merge our menu here, because we're going to have a very similar menu in the end to restart the game from scratch or quit it. Let's click OK. And you'll see that because we are not using our UI theme yet, the text is really small. So select the end screen node, expand the theme category, and we're going to drag and drop our UI theme.tres into the theme slot. Now for the play button, we want to change the next scene. We don't want it to restart from level 1, we want to restart from the main screen. So let's open our main screen scene in here to get the full path to it. So when you'll click play from the end screen, it will go back to the title screen. And so we can change the text on the play button to play again. The quit button can stay the same, so we can reuse our UI component as is, and all we are left with is the text. For the text, we're going to first search for our title scene, the title component that we stored, and drag and drop it onto our scene here. Click to select it, and we're going to change it to a message, end screen message, so congratulations, you finished the game. Then we want to reset with the title selected its layout too. We're going to align it with center top, click, shift, and drag to move it down. And under the title, select the end screen node, press Ctrl A to add a label. We will write the score in that label. So it appears in the top left. We're going to use layout, center top, set it to your final score is, we'll put the score there, you died X times. Now we're going to expand that property, so you can click the expand icon in the inspector to have a large text field to edit your text. And we're going to use some placeholders for the text that we can replace later via code. You can use the modulo sign followed by S to say replace that by a string later when we use the format function in GDScript. So we're just going to have these placeholders for now, and later via code we'll be able to insert a numeric value here. Your final score will be, let's say, 1000, and you died 3 times. We'll keep track of that a bit later. But for now, we're going to have it that way. So layout, I'm going to center top again to reset that. You could align the text centered horizontally, like so, and shift, click, and drag to place it under the title. So again, because these two nodes are attached to the top of our UI, it means that when we're going to resize it, because these two text nodes are attached to the top of the UI here, it means that when we resize the UI, they are going to stay at the same offset from the top. You might want to attach them to the center instead, so you don't get that collapse between the buttons and the labels. Going to select the menu, label, title. We're going to center them on screen and then manually offset the title and the label, place them above the buttons. Finally, you can select the menu, label, and title together, W to use the move tool, and shift click and drag to center them visually on the screen. And once you've done that, they will be relative to the center of the parent container. You shouldn't be worried about the text getting too large, for example, in some cases, because when you are creating games, you're optimizing them for either portrait, if you're going to make a mobile game, or landscape mode. The ratio of the supported screens will go from something around like that for the very wide screens to something a little smaller, 4/3, for example. These are the main ratios you should want to support, in which case the text is always fine. It's always going to fit in the center of the UI. And as you might have gotten by now, this is in part why we have all these layout options. This is so on different displays that have different ratios or sizes, you will have the UI elements centered or aligned and resized relative to some anchor points. Next up, we are going to add a system to count the score in a way that's persistent when we change the scene, so that we can show the player's score at the end of the game. To do so, we're going to use a feature called auto loads that relies on creating a node that will always be accessible and that we can use anywhere in our projects from the code. So let's go to scene, new scene, to create that new node. We're going to use the custom node button here to create a basic node. Let's call this one player data. It's going to store data related to the player. Save it. We're going to put it in the source folder, create a new autoload folder, and save it as playerdata.tscn. Now let's create a new script where we will manage the score. The thing to understand about the code we're going to put here is that any other script in our project will be able to access it. This node is going to count the score and the deaths of the player. So let's create two variables to store these values. Variable score is going to start at 0, and we're going to create a variable deaths that's going to start at 0 as well, 2 integers. And we're going to do something there to be able to notify the rest of the game that we updated that node so that the user interface will be able to react to it. So we're going to use signals for that. At the top of the script, let's create two signal updated, and a signal called player died. So updated, you could say values updated, something like that, for example, or we're going to call it score updated to be a bit more precise. We're going to create two functions so that every time we change the score, so if in some script you write score plus equals 1, like so, it's going to go through a function that will increase the score variable and call the signal here. For that, you can use a feature in GDScript called setGet. The setGet keyword allows you to define a function that every time you're going to change that variable, it will send the new value to that function that will process it. So setGet, set score. This is called setting up a setter function. And after the setGet keyword, you first write the name of the setter function, the one that will update the variable. And optionally, you can add a comma and add a getter function, one that will return the score value to the user of the variable. Now we're only going to use a setter, so a function that is going to be called every time we change the score itself. Let's copy this function name and create it to clear the error in the script. So function setScore. Every time you have a setter, it's going to get the value that you want to assign to the variable. You want to make sure that this value is an integer in that case, that is to say a whole number, because that is what our score is, and this function will not return any value. I'll just put the return keyword so we don't have any error here, but to explain, imagine that we're in another script calling player data.score plus equals 1. Add 1 to the score. I'm going to comment that out. What's going to happen is Godot is going to call that setScore function with the new value of the score. So the current score, 0 plus 1, so 1. Then it does not modify the score variable. This is up to you to do it. So every time you create a setter function, the first thing to do is to say score is equal to the new value passed by the function. And then you can add extra instructions that Godot can follow. In our case, emit signal, and we want to emit the score updated signal. So that way the user interface will be able to listen to that signal and get the new score value at that point from our player data. Or, optionally, you could make your signal pass the score value. So you could pass score, or in that case, value. Both variables at this point will hold the same value. But in our example, we chose to not pass the information through the signal, as anyway, everything's going to use that player data directly. We're going to do the same for the defs. So at this point, you should be able to replicate what we did for the score using the player died signal instead of score updated. I'll let you pause the video and do that. And so it looks like that. I'm going to copy the setGet keyword, set defs. Note that the convention for setter and getter functions is to call them set underscore followed by the name of the variable, and for getters, get underscore name of the variables. So I'm going to copy and paste the setScore function and rename score to def in here. One thing we can do there is use the Control-R shortcut to replace in the selection only. That should be automatically checked if you made a selection before calling the shortcut, and you can replace score with defs and click replace all. And finally, after you've done that, you want to change the signal name to player died. Now we're going to register that scene, that node, as an auto-loaded node, because right now, if I go, let's say I'm going to open my player script. If I try to type player data, Godot is not going to find it. It's not globally registered yet. So we want to go to project settings, and there is a tab dedicated to the auto load. So click on that. Then in the path, you want to go find your file, playerdata.tscn. So go to source, autoload, playerdata.tscn. Note that we don't actually need to make a scene. As long as your script inherits from node, it is enough. But let's do that now. And it will give that node a name. This is the name you will use to call the node to access that new player data class in your script files. So the default player data is fine. Let's add this and close here. Now we have that autoload registered from anywhere in our script. For example, when the character dies, we can say player data dot defs plus equals 1. So now we are going to code the def a little bit differently. We're going to create a die function on our player. The reason being that if you want to add new ways for your player to die, you don't want to hard code the death in every block, in every signal callback, like when the enemy touches you. So instead, we're going to create a new function called die. So you can write that here. It's going to give you an error, and go to the bottom of the script where you will create a new function called die. It's not going to return any information, and we're going to increase the number of defs. So player data.defs plus equals 1, and we're going to Q3 the player. And with that, it should clear the error, and we have the player def coded. We don't have much more to do. We will automatically later on show the user interface when the player data singleton or autoload emits that player died signal. Now we are going to work on the score. So the score will increase when you stomp an enemy or you collect a coin. Let's go to the enemy scene. So Control-Shift-O to open the enemy scene, and it will automatically open the enemy script. We had a die function already there. So now, when the enemy dies, we want to increase the score. And to do so, we're going to create a new variable, so an exported variable called score, which is the score value of the enemy. So let's say it's 100 points here. Then, in the die function at the bottom of the script, we're going to increase player data.score by the enemy's score value. We finally have the coin to take care of, so let's open the coin scene. And when the coin is picked, we also had a function for that, because we are going to increase player data.score plus equals, let's call the value score as well, while we had it already on the coin. And so we're going to increase the score by 100 when the coin is picked. And that is it for the score system. That is all you need to make it work. The score and the death count will be persistent between the different scenes. Now going back to the player data scene and script, we're going to add one last thing. We're going to add a function to reset the score and the deaths when the player restarts the game at the very end. So let's create a new reset function. It's not going to take any parameters, and it's not going to return anything. All it does is reset the score to 0 and the deaths to 0. And there I have to add a little precision regarding the way setters work. Setter function, so set score and set deaths, are going to be called every time you change the score from the outside. So if we go to player.gd, we do player data.defs plus equals 1, it's going to go through that setter, set defs. But when you write score equals 0, defs equals 0 inside the class, like so, it's directly going to modify the variable without going through that function. This is there for flexibility, so that internally inside your class, you can make changes to the variable when you need to. Like in our case, we don't want to emit the player died signal that later on will trigger showing some bit of interface saying you died, restart the game, etc. We just want to reset the values. So that's what we are doing. But with that, let me show you one thing. We are going to play the game, so press F5. We shouldn't have any errors. And then in the top left, you have a remote tab in the scene tree that appears. And that remote tab is going to show you the state of the game scene tree in real time. So you can see one thing. We are in the main screen scene, and we can see our nodes, our UI nodes. Player data is also there, automatically loaded for us. This is why these nodes and this feature is called auto load. Then if I click play, the nodes change in the scene tree. So we have the player and all the level, the tile map, etc. but the player data did not change. And this is what these autoloads do. Furthermore, if you look on the right, I've selected the player data and you can see live its values. So you can see that as I move the player around and I collect coins, the score value of my player increases. Now I'm going to die and the death count increased as well. With that, in the next video, we can add the game user interface, including the pause menu. In this video, we are going to add the user interface in-game, so the text that will display the score and the pause menu and the corresponding overlay. It's going to look something like that in the end, with 3 buttons that allow you to, say, quit the game if you want to. So back from our main screen, we are going to create a new scene for our user interface once again. So we're going to start by calling the scene user interface and saving it to the disk in our user interface folder. Let's start by adding the theme so that our UI looks consistent with the main menu and the end screen. So we'll put it just on the top level user interface node, and everything else will inherit from our theme. Then let's create our score. So our score is going to be a label that will anchor in the top right of the screen. So go to the layout menu and top right. This means that when you click and drag on the node to move it, it will be relative to the top right of the screen. You can align the text to the right in the label, and let us type our template text score, colon, and modulo S. Remember, this modulo S is a template that we will then replace from the code. I'm going to move the node a little bit again so it stays in the top right of the interface. All right, with that, we have our score label, really. We're going to create the pause overlay straight, and we're going to create it inside that scene. So we're going to start by making some color rectangle that's going to cover the entire screen. So let's add a new node and look for color rectangle or color rect. Then with that new node selected, go to layout, full rectangle. So as you can see, it's just a colored rectangle. We can change the color in the inspector. We're going to go for a transparent black overlay. So click to open the color picker, drag to get some black color, and then we have to change the 4th channel. So we have RGB for red, green, and blue components of the color. And to change the transparency, we want to drag the A for alpha. So go down to something like 60, a light overlay. Then we're going to create our pause menu. So we're going to have a title and then a list of 3 buttons. Let's go to our source folder, user interface, and we have title that we can click and drag inside our color rectangle that we'll rename to pause menu or pause overlay, because this node is just the overlay, it's not the menu itself. So we're going to have our title called paused, like so. We're going to center it and move it up a little bit. Then select the pause overlay node to add a new node as a child of it with Control A, and we want to look for VBox container again. So vertical box. Go to layout, center to center it, and we're going to use the Alt key and click and drag on the corners to resize it around its center. Let's make it something like that. A box that has enough space for the 3 buttons we'll put inside. I'll move the title up a bit. I rename the VBox container to pause menu. And then we want to add our quit and scene change buttons inside. So you can go to the file system and select the 2 scenes and click and drag them inside the scene tree. and you can see the blue bar under pause menu, which means that they will be added as a child of the pause menu. Then, if your buttons are properly set to expand, they should take all the available space here. Let's take the scene change button in the scene tree, and there's a shortcut to move it up and down the hierarchy. Control up arrow to move it up, control down arrow to move it down. And look in the view how the order of the buttons change. This is really the magic of these UI containers. Now, we're going to have our scene change button right down main screen. It's going to go back to the main screen. And for the scene path, we want to go, so in our file system, to the screens, main screen, you can right-click to copy the path here, and right-click to paste the path inside the next scene path slot. And that way, our button is set up. Now, we need to add one new type of button, a button to retry the current level. So we're going to create a reusable scene once again. We're going to get either button, quit all scene change button, right-click, duplicate the scene in the file system tab, and let's call this retry button. Press enter to create it, and double-click to open the scene there. Now I'm going to rename the node retry button, and we want to change the script on it. So I'm going to click the remove script icon and click again to add a new script. It should save automatically to the right path, user interface /retry button.gd, click create, and there we're going to have a similar setup to what we had before. So note that the signal connection is still there, and it's still on button up, going to call an underscore on button up function. So I'm going to type function on button up. It's not going to take any parameter, and it's going to not return anything either. When we want to retry the level, here's what we want to do. First, we want to set the score back down to 0. It's going to update the score in the user interface, but we don't want to reset the defs. This is why we don't do player data.defs equals 0, or we don't call player data.reset, right? We just want to set the score back to 0. Then we're going to reload the current scene. So get tree, because this function is on the scene tree node, so we have to call the getTree function to get that node, dot reload current scene. And finally, we'll do one more thing ahead of time. We're going to add a pause system, and the pause system is built into Godot. So you can call getTree to get the scene tree again, and this scene tree has a property called paused. So you can say paused is equal to false. So what's going to happen is, because that button is in the pause menu, you know that if you are clicking that button, it's that the game is currently paused. So when you click it, you are going to unpause the game so that when we reload the current scene, you can play instantly. And that is it. We can save, close the scene, press F1 to go back to the 2D workspace, and click and drag the retry button in our pause menu. Oh, I forgot one thing, so let me reopen the retry button scene to set the button text to retry. Go back to the user interface, and voila, we have our full pause menu. In the next video, we're going to code our pause system on the user interface node. Back to our pause menu, we're going to code the pause. So first, I want us to set the default state of our menu. We don't want the overlay to show in-game by default, so we're going to toggle the visibility off. Then select the user interface node, and let's create our user interface script. There, we are going to manage the pause state of the game and a little more. We'll see that afterwards, like put some label when the player died, etc. Anyway, we're going to create a variable called paused to manage the parsed state of the game and of the interface as well. And we're going to use the setter function, the setter feature of Godot, to go through a function whenever we parse the game. So let's create that function. The reason for that is that when you parse the game, you not only want to change the parse state of the scene tree, but you want to toggle this menu on and off. So we're going to create a setParsed function. Again, it always takes a value, a Boolean in that case, so true or false, and it does not return anything. Now, first thing to do with a setter is to assign the value to the variable that you want to set, to change. Then we are going to set the scene tree to be the same state as our parsed value here. And to do so, we are going to cache the scene tree. We are going to get the scene tree node and store it in a variable. And we can do that using an onReady variable. So the onReady keyword, remember, triggers right before the _ready function in Godot and allows you to get nodes and to store that in memory. Because getting nodes all the time, if you have a very large game, can start to use quite a bit of CPU, to use quite a bit of performances, so it can be nice to do it ahead of time. So scene tree, we're going to call the get tree function here at the start, and that way within this script we can use the scene tree variable to refer to the scene tree node. So in our setParsed function, we're going to write scene tree.parsed, and you'll see you get full autocompletion thanks to the type hints here. We're going to set it to our value here. But that's not all. We're also going to change the visibility of the parse overlay. And so this is a convention we use at GDQuest where we cache what we call the dependencies, the other nodes in the scene or outside the scene that we use inside a given script. So I'm going to create a new onReady variable for my parse overlay, and we're going to get the node called parse overlay here, right? And for the type, it won't give you an error if you use the automatic type like that, but you can say that this is actually a color rectangle here to Godot, because by default, if you only have the colon, the type that Godot will use here is the return type of this function. You see, when we write the arrow after a function, we tell Godot which type this function is going to return. And getNode returns the type node. But if you want to be more specific and get better autocompletion, you can tell Godot what is the exact type of the node that you are getting. In this case, color rect. So what I'm going to do then, parse overlay dot visible equals value. Okay, so next up, we want to parse the game, to use that parse variable. We're going to do that with input. So let's add a new parse input event. Go to project, project settings, input map, and let's create a new action called parse. Press enter to create it. I'm going to click the plus button here to add a new key, and we'll use escape to parse and unparse the game. Now, in our user interface script, around the top, we're going to add a new unhandled input function. It's one of the built-in callbacks that we've used for input, right? And we're going to check if the event or the input event parameter that we get corresponds to the action parse being pressed, in which case we will toggle the parsed variable. So I told you that if you say just parsed, it equals to, well, we can use not parsed or the exclamation mark to negate the value. So it means if you have a Boolean like that, if it's false, set it to true. If it's true, set it to false. In other words, toggle the value of my Boolean variable here. I like to write using the not keyword because it's plain English, right? paused becomes the opposite of the current state of the variable. Now, if I do that, it's going to change the variable directly because we're within that class and not go through the setter. There are two ways to go through the setter. The first one is to directly call the function inside the class. The other one is to use the self keyword, which is what we generally use at GDQuest. So self.paused will ensure that the variable goes through the setter function. This is because when you call the variable from another script, say from my retry button or whatever, you are implicitly going through that self. Godot is going to say, I want to change the pause variable of this instance of the user interface. So we're getting a bit more technical, but what we have to understand there is that in many programming languages, you have to explicitly write that self dot or this dot in your classes to refer to a variable that you created inside that class. And in GDScript, it's not the case. Most of the time, it is implicit. But in this one case, we need to make it explicit for Godot to go through the setter here. Finally, whenever you go through that unhandled input function, we don't want anything else to intercept that event if we already paused the game. So one thing you can do here is on the scene tree, call the set input as handled function. Whenever you press a key on the keyboard, all the nodes in the game that have unhandled input or a similar function will receive that event. And if you have two bits of your game, like your user interface and your player, that react to the same events, for example, pressing the arrow keys, you can use set input as handled to not propagate the event, right? So it will stop here. Only this function will process the pause input event. Now at this stage, we can test the pause system in our game. So let's save and go to our level here, the first level. We're going to add the user interface there, but if you directly add it, you will see that it gets collapsed to the top left corner of the screen, and so the score label shows at an offset of that. We want to use a new layer, like we did for our background, to separate the UI from the rest of the game. So select level 01, press Ctrl A, and create a new canvas layer. That layer is going to be, let's call it user interface, and we're going to place it around the top of our level here. Make sure with the node selected that we set the layer to a high number so it shows in front of everything else. And then click and drag user interface.tscn under that node. And you'll see that now it resets, it takes the entire screen. With that, you can press F6 to try the current level. Press escape and you will see the game pause, so the enemy stops moving magically. Now, if you try to click the nodes here, you try to click the buttons or press escape, you will see there's a little issue. I told you the pause system is built into Godot, and by default, when you set the game to paused, all the nodes in the game, like the enemy in the background, it stops moving, it stops processing, it stops reacting to clicks and to signal callbacks. So I'm going to quit the game here to stop it with F8, go back to the user interface, and with the user interface node selected, you want to go down to the pause category. And the mode by default is inherit. So it will inherit from its parent, which in this case is the user interface, which inherits from level 01. And the default mode for the top level node is stop. When you pause the game, everything stops as a result. Going back to the user interface scene, we're going to set the mode here to process, which means that whenever we pause the game, the user interface will not pause. We will still be able to use it. So let's go back, press F6, and so I press escape to to pause the game. Now I should be able to retry the game. As you can see, escape to pause, and I can quit. So that way you can test your user interface and see that it works, and that the pause works in just a few lines of code here. Next up, we're going to connect the player data node, which is auto-loaded in our project, so accessible from everywhere, to this user interface. We're going to do that in the ready function because we need all the nodes to be loaded in memory. Let me fire the game just to show you the remote scene tree. So the ready function gets called on every node from top to bottom. So let's say the root node, but then player data. And when it hits main screen, it's gonna not call ready on main screen, it's going to start with its children. So texture rect title. When it hits menu, it's gonna jump to the children, play button, quit button, then menu, and finally main screen. So it goes in the tree order from top to bottom, but then it starts from the deepest children to the parent for each branch in the tree. This is why the auto-loaded nodes will be available in the ready function. They will be loaded before everything else in the game. That is why we can directly call playerData.connect, and we're going to connect the score updated signal to this node. So we have to use self as the second parameter. And we're going to call a new function that we'll call update_interface as a callback for that. I'm going to expand the view as well here. So every time that the score gets updated, we're going to change our score label here. Then we are going to connect the died signal to another function. Let's do that. Let's do the two connections. So I'm going to duplicate this line with Control B, and instead of score updated, we're going to connect player died here, and we're going to connect it to an on player data lowercase player underscore died. And finally, at this point, so we're going to use that update interface function to update the score, and we'll call update interface here, which is going to give us an error because we have to create that function. So copy this update interface, and we're going to place it above our setter down there. Function update interface, it's not going to return anything, and in this one we're just going to update the score label. So the score label is our label here, and I'm going to create a new variable at the top of the script to store it. So onReady variable score colon label, it's of type label, and we can get the node label here. Again, if we are doing that at the top of every script, it's for code readability. Anyone opening our user interface can look at the first lines with our convention and understand that this node depends on the scene tree, on the pause overlay that you can see here, and on the score label. And this helps a lot when your game grows. So that's why even if we could directly call getNode inside our functions, we are trying to give you good practices for your future projects here. Okay, so I'm going to do score label dot text is going to be equal, no, I called it score dot text is equal to, and we're going to use the same template as in our score label. So score colon modulo s, and then you can use the modulo sign followed by a value that will come and replace your modulo s here. In our case, player data dot score, and will automatically, when we play the game, replace the modulo s. So you can play level 1 where we added our user interface already, and you can see that the score is set to 0 at the start, and as you hit the coins it goes up on the UI. already. We have one last bit to do. It's to react to the player dying. And the thing we're going to do there is we're going to pause the game. So it's going to show our pause menu, and we will change just the title of the pause menu. Instead of writing paused, because the death menu will have the same options, retry, main screen, and quit, we're going to have a different text, you died, or something like that. So let's copy the callback function we have in ready when we connect to the player died signal. And right under the ready function, we're going to place that function, player data player died, or I need to add an on here. I'm going to select the text, press Ctrl R to search and replace, and I'm going to replace the text by on underscore player data player died. Replace all. Okay, so this function, same thing, it's a void function, it does not return any value. And there we're going to pause the game, so self.paused equals true. And we're going to update the title label in our pause menu, pause overlay. So for that, again, we go back to the top of the script, we duplicate the score here. We're going to call it pause label or pause title. It's going to be of type label, and we're going to get start to type pause, and you should find pause overlay / title autocomplete it for you. And so now going back to our on player data player died, we're going to get our pause title dot text is going to be equal to you died. There you go. So I know that mechanic of jumping back to the top of the script, adding these onReady variables and jumping back down, and the way we order the code sometimes can seem a bit messy at first, but again, the goal is to make the code as easy to read as possible for your future self, to understand the code you wrote months ago, or for your teammates. It's exactly the same thing. And the conventions that we use at GDQuest, we've worked a lot on that to optimize them so that, for example, when we connect to signals, we generally do it in the ready function of our nodes. So it makes sense to have the callbacks, like on player data player died, as close as possible to your ready function. That way you can see the connection and you can see the result really quickly. The exception to that rule is when you are using a method that other nodes, other parts of your game may call independently from the signal, like we're doing with update interface. Anyway, with that, we have our pause menu. You have to make sure that the pause overlay is hidden by default. And then you will need one more thing in this project. It's to copy that user interface bit, the layer and the user interface scene, to the different levels. So I'll open level 02 in my game. I'm going to right click, merge from scene, and I'll go find my level 1 where I created my UI setup. So I'm going to go to levels 01 and I want to copy the user interface. Okay, it will probably be added to the bottom of the tree. I'm going to put it back at the top, and voila, we have our score in the second level. You can do that as well in the level template. So I'm going to Control-Shift-O, open level template here, and in my level template I'll do the same. Right click, merge from scene, go to level 1, double click user interface, and place the user interface at the top. With that, you have your in-game UI. We have one thing left to do, to change the end screen of the game. So let's open it, Control-Shift-O to open the end screen scene. And remember, we have that text, your final score is something you died X times. Well, we have to replace that with a bit of code. So select the end screen node. Let's add a script, and we're going to create it in the end screen folder. Now, we're going to first get that label that we need to change, the one that has these template strings. So going back to the script editor, F3, I'm going to type unready variable. We're going to call it label. Label. It's of type label, and it's the label node. I'm going to use the getNode function for consistency in our project. Note that what I was doing here was typing the $sign, which is a shorthand for that. I think I've mentioned it in the course, but just in case. We don't really need a function to change the text. When we arrive on the end screen, we're going to change scene from the second level to that end screen scene. So we will get the ready function of the end screen node called. Let's create that ready function. And this is where we're going to change the label's text. So label.text is equal to label.text. So we already have the template here with the modulo S for the score and the defs. So now all we have to do is to use our modulo sign, which is the symbol to format a string to replace the templates that we have. And then we have to pass in first the score and second the number of defs, the defs count. And we have to pass it inside an array. So we're going to create an array like so using the square brackets. And first we pass player data.score. And second, we're going to pass player data.defs. So now, if we go back to the scene and we play this scene with F6, we should get 0 for the both of them. If now I play level 02, I'm going to double check that our Portal 2D here, the next scene is, let's see, level 2 is not linking to the end screen. So now we have to go find the end screen in our file system tab and click and drag it onto the next scene slot of our portal. For testing purposes only, I'm going to place the player closer to my portal here and press F6 to play. So all I want is to check that the score is working. I have a score of 300. I pass the portal and I get to the end screen. The final score is 300. Let's do another test. I'm going to fall down, die, retry, and then jump to the portal. And the death count works. We died one time. We have a score of 300, which corresponds to getting or grabbing 3 coins. Now, let's test the final game. So if you have set up all your portals right in level 1, level 2, you should be able to play the game and have all the connections work. I'm going to make the game full screen. So go to Project settings for that. And in the search bar, search for full screen. It's in the display window category. Check the full screen checkbox. And when you press F5, the game will be full screen, as you'd expect. So let's play it, and there I want to thank you very much for watching the course or this video to the end. If you were just interested in the UI part of the course, now you have an extra lesson in the extended version of the course in this chapter as well about creating a UI theme. But you can pat yourself in the back for getting there. And with that, I want to thank you kindly for watching. Be creative, have fun, and let's see one another in the next one, which can be another tutorial, another course. Thank you very much. See you soon. There is a bug that happens in the game when you die that someone who played the game reported. So when you are dead, you can press escape to unpause the game. In which case you have to know that you have to press escape to open that menu again. We might not want that. I'm noticing that the you died is also a bit offset here, that we have to recenter it. But first things first, we want to prevent the player from unpausing when they are dead. So for that, let's open the user interface scene, and the pause menu is controlled in the user interface script. So let's open that. So when you die, the player died signal is emitted, you pass through that callback function, the game is paused, opening the menu, and the title is set to you died. This just pauses the game, but then if you press the pause action, escape, in our case, it's going to just unpause the game. So here, we could add a new property to say that the player is dead, and just if it's dead, you don't unpause. Another option is to use the pause titles text to check if we're on the died menu or not. So we can say if the action pause is pressed in the unhandled input function and pause titles text is not equal to you died, then we can unpause the game. Look at the result. Well, I'm going to die here. If I press escape, it's not going to do anything in that case. I can only click the buttons. Retry, retries the game, etc. Bug fixed. This might seem strange to some of you because you'll see that a lot of people will use booleans, will add extra variables to handle those kinds of problems. It's actually something you should avoid. The fewer properties you create in your code, the fewer bugs you will create. This is not necessarily the best way to solve the bug while really patching the game here. You might want to move that message to some constant. For instance, we could have a constant at the top of the script. Side message. And you could say you died. That way you can't make a typo if you replace the hard written message by the died message constant. And that is it for this issue. When it comes to the text title, it's already set to be center aligned, and I think that the align problem comes from the text box, that when you change the text, we can try here, you died, yeah, it's going to push the text box to the right. So the issue is that there is not enough space in the text box to make room for the you died text message. So we have to alt-click on the handles with the move tool selected as usual to make a little more horizontal space for the you died text. Another option to fix that bug would be to have a completely different pause menu and you died menu with possibly different options. That would probably be more flexible because in a full game you might want to differentiate the two menus, to have an inventory, to have something in the pause menu, but when you died to only have retry, main screen and quit, for example. With that, if you find any bug, you can find a link to the code repository below the video. I invite you to report issues there. Congratulations for getting to the end of the course, and thank you for watching it until the end. I hope it was helpful. Please tell me in the comments below if this was helpful. For one, what you liked in the course, and if you have anything you'd like to see us improve moving forward. I don't have a lot of experience making beginner-friendly content, so that would be most valuable. Now, you should subscribe to the channel because there's going to be more moving forward. We want to keep creating free content like that. We have our 3D mannequin that's open source now. It's not necessarily a beginner-friendly thing, but it's a professional-grade game character that you can use to prototype your games. And we have James, who's working on a beginner-friendly first-person shooter tutorial series. But that said, I want to thank you kindly for watching. Be creative, have fun, and let's see one another in the next one. Bye-bye.